What's up, man? Just getting it set up. Can you hear me all right? Well, greetings from Philadelphia. I'm doing a last minute, like, super crazy setting this all back up because my second camera went down. So this camera over here... Oh, is it frozen? Oh, there's a wicked delay. Holy crap. Yeah, this camera right here is just a super junky webcam, so what are you going to do? Wow, that's a long delay. That's going to freak me out. Let me see if I can change that delay and not break anything. No, I'm on low latency. I see rails and I like it. Yeah, we'll go over the rails a little bit. Yay, pop-up windows. Yeah, we'll hit on the hot end too. I don't think I can move this stupid chat window. Alright, bear with me here. How's it going, Peter? I'll start saying important stuff in like, 8 or 9 minutes. So. You hate the cantilevered style. Well, this has a few tricks. It doesn't have to be cantilevered. It just is at the moment. That was actually part of the test. Well, we'll get into that. Just getting all my windows set up. Hello, auto exposure. Stop that, please. Alright, I'm just going to go wash the grease off my hands, then I'll come back and start this up. So just give me like 2 minutes. All right. I'm not sure if you're all seeing the delay that I'm seeing or if you're on a different buffer, but regardless, I'm just going to start talking now. I'll tell you a little bit about how the stream's set up, and then we'll get into the printer stuff. So this, because I had to swap out my second camera at the last second, I don't have fancy stuff set up with OBS. I'm just broadcasting whatever's on my second monitor. So I can go like this and just drag stuff up there and show you and then drag it back. It's not the most efficient way to do it. It's probably not the best picture, but what are you going to do? No delay? Awesome. Yeah, the audio was also out of sync with everything, so I had to manually set a delay on the audio to sync it up with the video. So I think it's all right. It seems okay over here. Okay, as far as the chat and everything, I have live chat set up. I'm watching that. I think super chat's set up. You can try that if you want. I don't have like a moderator in this, so I have all of the default settings set pretty conservatively. So like if you type all caps, it's probably gonna like delay you or ban you or something like that. So just be careful about that. The adult language filters on too, so it might filter you out as spam if you do that. So just, you know, be careful about it. Doesn't bother me, but that was just one of the options that I had to toggle on here. And I think it has spam filter on it too, so you can only post once every 30 seconds or something like that. So yeah, anyways. No, you're early. Yeah, I'm talking about the stream a little bit early, and then at 2 I'll get right into the printer. What's up, Mega Making? I also have a very cluttered desktop here because I had the if you remember, there were a couple of videos I was getting really bad buzz, and part of it was my hardware compressor was going bad, and part of it was this second monitor, the power supply buzzed really bad. So I grabbed a new old monitor and stuck it up there so I wouldn't get a stupid buzz in the background, but the adapter for this monitor didn't come in time, so I have everything crammed on the one, which is super annoying. How long do I plan on going? I blocked it out to go from 2 to 4, so just a couple hours. I didn't want to talk anybody's head off. That was before I changed the plans on what we're going to do. I changed it to like we're going to talk about features of the printers as opposed to like me sitting here and building it, because I thought that would be kind of dumb. So we'll see. So probably a couple hours, unless I run out of things to say, which never happens, by the way. If you stacked fast switching low RDS on high power MOSFETs at the output of a 2208, for example, would it actually be like a TMC on steroids? The TMC, well, the MOSFETs are already in an H bridge and you have an output. So, but the 5130, I think, is designed to have external MOSFETs. So you could put whatever MOSFET you want on that. They have some specs, and that was, I keep teasing like doing a torque comparison video for like a whole bunch of different steppers, and that's the main thing that's been holding up, is that stupid 5130 or 5160 or whatever, because they promised a step stick format, and I've actually seen prototypes, but like I don't have one. And the bill of materials, the board files, all that have been on Trinamic's website for like since the middle of last year. It just hasn't come out yet. But yeah, that has the board and the controller, and then you put 4 little MOSFETs and an H bridge on the chip. So yeah, you could make a Trinamic on steroids with those, which is why I'm excited to see them. They're just not around yet. gonna start in a couple minutes here. Have I tested real Gecko drivers? I haven't tried Gecko drivers on a 3D printer. I'd like to, but they're like 150 bucks a piece. I'd also love to try the, you know, the Trinamic industrial drivers with the ramp generator and all that, but I have not. I have way more ideas than time, and way more ideas than money. Did I post a guide on making a board from scratch? No, not yet. That's coming. All right. Just opening all the softwares here and making sure it doesn't want to do a stupid update before I start. Oh, you do want to do a stupid update. Oh, don't update my compiler now. Thank you, Microsoft. The 5160s are at Voderot now? Ooh. Well, if that's true, I will get some post-haste. Yeah, I saw the... Oh, they are coming out in Steps format from Big Tree Tech. That's good, because I saw the ones that are available, and they were the big old the BOB, the breakout board format, which you could get from DigiKey for a while. It's just meh. Okay, 2 o'clock. Let's get this started. All right, so here's what this is about. This is what we're going to do. This is a printer. I designed this from scratch, and for experimental purposes. And I plan on doing a couple things like this. I like building printers from scratch and trying a bunch of wacky things to see what works and what doesn't. And you kind of design them around a theme. So you have the luxury, if you're not designing for a company, if you're just doing it for yourself, of doing whatever crazy stupid thing you want. So like I said in the intro to this thing video, the inspiration for this one was the cheap linear rails, because because the Highwind rails are pretty expensive. These I got for like $8.80 a piece, and I wanted to give them a whirl, and I sort of designed everything around it like sight unseen, just to see how they worked out. And then I did that video with like the rebuilding and everything, because I found out there was like debris in there and the bearings were the wrong size and that type of deal. But unfortunately, even with the bearings the right size, after I used it for a while, they developed a little bit of play. Now, I don't know if that was like an initial settling in and now it's going to be fine, or if it's going to continue developing play. So it was actually affecting print quality. So as far as a cantilever printer like this, for the Z-axis, I actually went to Adafruit, and I got a heavier duty rail. This is one of the 15 millimeters. It's still not like a Highwind or an Ico or Nikon or something like that. It's a clone, but it has dual layers of recirculating bearings, and there's a lot less play in it. But it was pretty expensive. You could probably still do it with one of these for a printer that's this small, but I thought I would give that a try too, so I could kind of do it all at once. Also, I decided to go with a direct drive extruder, and that was obviously a lot more heavy. So anyway, I don't know how I'm going to show you these things here. Grab the camera and move it around. What I did with the cheapy rails is I took one of there we go. I took one of these V-rail wheels, put it on the top with just a couple of screws on the axles to tension it against it. That way, where did I put? Oh, there it is. because these have, and I don't know if this play is intentional or not, because these say they're self-aligning, so they do have slight movement this way, but they were rattling around. So what I did was put wheel on the back to kind of tension it against there, and that cleaned up all the slop. And I did that on the X and the Y axis. It prints without it. The problem is you hit resonance really easily on that axis because it's kind of free moving, and you get these little brrr, like wavy patterns in the print, which was obviously no good. However, if you did use these rails parallel to each other and sort of pre-tension them to each other, or if they sold, and they do say they sell these pre-tensioned, as opposed to this, which is obviously free moving, that would probably be all right. Unfortunately, those were not the ones that were on sale. But if you could get these and pre-tension them against each other, or strain, stress, whatever, against each other, that would keep that from rattling and be okay. Now for this guy, I wanted to kind of see what the limits as far as length were on this, so I just used a standard Prusa bed, so that's like a 220 by 220 bed, and see how well the cantilever would do, because these do have, you know, they're going to, any cantilever design, have some kind of flex, and I want to see how well the rails would deal with that. And it ends up they do deal with it very well if you mount everything rigidly. I haven't really had problems because of cantilever sway, except a little bit front and back on the x-axis, which isn't quite as vital as the other direction. But to hedge my bets, I designed this so that I could run a longer rail in the back and then stick a second rail on this side, and then have more of like a standard, you know, I3 but with linear rail type deal, and then be able to tension that and not have to worry about the wheel on the back. Oh, that's what you meant by burnt. Yeah. Oh, in the video, they had the burnt video. No, there was a, when you have that set really fast, you get a lot of burnt when it's doing the stuff. Anyways, so where was I? Yeah, one of the things when I was messing around with the cantilever stuff is we have certain habits that we sort of inherited from like the original RepRap project, which was fine and all, but a lot of that uses 3D printed parts to hold load-bearing parts to load-bearing parts. And in some cases that's okay. For example, like I think Prusa still does it like this, where you have the LMU linear rod bearings that are set into a 3D printed part, and that's okay. But when you're talking about a cantilever printer and all the weight that's on this, that's kind of a problem. So what I wanted to try here was to see if, instead of 3D printing parts or using like a bolt-on corner, I would just drill through the linear rail on the side here and mount a bolt directly to it. So then the printer would both be perfectly square and the stress would be aluminum on aluminum. So the only flex that you would get would be from the rail itself, which isn't going to flex very much. So that's how this is built. This is a 40 millimeter by 20 millimeter rail back here that does the cantilevered part. It has, well, it's supposed to have 2 bolts. It has 1 right now, but 2 bolts holding it through here and 2 bolts on the other side. And then let me move this up so maybe you can see this a little better. I have a 40 by 40 like Cetus type big chunky rail over here that's taking up a lot of that flex. So it doesn't really have a whole lot of flex in design anyway. Mostly what I found after that was all rigidly fixed was when you have the type of cantilever design, you have this L shape, the whole thing tips that way, so it needs to be mounted on a platform, obviously. So the only flex that I was getting is from the platform, and that wasn't deforming the print, so it was actually pretty good. It was better than I expected. Not as rigid, obviously, as like a box frame printer, like you see a lot of the, you know, Core XY types or whatnot, but definitely better than like the regular linear rod type, like old i3, you know, version 1 or version 2 type printers. So I was pretty happy with that. Let me see, what else do I have to hit on real quick? Oh yeah, I already had a question about the extruder. You can see this monstrosity here. get that out of the way. What about a granite and epoxy frame? I can get into that in a little bit. Let me talk about the extruder first. So this, I wanted to mess around with a belted extruder. So this is a 3-to-1 reduction ratio, and it's a 3D printed type of a sandwich deal, and it's running on bearings here and here. So it has 3 bearings there, and this is just a bolt running through the whole thing in a feeder wheel on the other side. It has a little quick release mechanism for loading and unloading, and then obviously this is the thumb tensioner here. Now, one problem that I did run into, which I guess is a beware, is you'll notice there's 2 different fans. I think you can see that, 2 different fans on the sides. I bought these originally. These were the ones that were in the fan test where I was blowing up plastic bags or balloons. I don't remember which I ended up using. And then I decided to go ahead and get the slightly bigger ones. So I got 2 of each of these, but my power supply, which you can probably hear because the stupid fan is so loud, I overvolted that a little bit to 27 volts as opposed to 24, and it ended up frying the other fan. So I just tweaked that down to like 26, and then I replaced it with this one. So that's why, before anybody asks, why there's 2 different fans on there. Alrighty. And this is the filament that I got specifically for this stream, because I usually print, the way that I do it is I'll do clear filament, just whatever's cheapest, clear natural virgin PLA for the prototype stuff, because I figure I'll be blowing through this a lot and I don't want whatever, colorations and additions are in there. And I throw those in a bucket, and hopefully someday I can grind them up and reuse them as filament. Then when it gets a little bit more settled, I'll use like a gray, and then when it gets to the final version, I'll use black. So then I know if I just pick up one of these parts without having to like study it and see what's going on, I can say, oh, this is a beta part. So yeah. Anyways, but I bought this for the stream, and it's a great color. It almost matches the curtains. But that's from Atomic Filament. Figured I would drop them a line because it's pretty nice. The color is dark cherry red PLA. So if I could get this in matte, that would be like the perfect color. But this, I did 2 prints in the cherry red just to make sure the printer was still working this morning when I got it up. But anyways, so this came out fine. And then I just did a calibration cube. Get a drink here. Alrighty. What other weird things do I have to get in before we talk about firmware? Oh, yeah. Okay, so the bed, the belts, and the Z-axis. I had a lot of luck with the Z-axis on... It's buried. My test bed printer, where I used a pillow block to take the strain off of the little shaft coupler and to keep it straight. I had absolutely beautiful layers on that printer. Here's one of the prints from that. Hopefully that'll focus in. Nope, not high enough resolution. Anyway, they were absolutely beautiful, so I figured I would try using a thrust bearing. That didn't work great, so I went back to the radial bearing with the drill stop on it, and I'll show you that when I get to doing videos for this. But it did turn out pretty well. Next thing, the bed. So this was, somebody mentioned Cetus before, like, I'm not a big Cetus guy, but I liked the way that they used the fixed bed on there as opposed to the bed that was mounted with springs, because those springs, unless you use like higher tension springs, they tend to have a little choing, 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 and that contributes to ringing a whole lot. So I decided to use a fixed bed and then use auto bed leveling just to make sure the whole thing was level. So my first thought was to go on AliExpress. This is how stuff usually comes from there. And to grab one of these big, crazy, thick aluminum plates, but this was super heavy. Now, you do, because you don't have the spider underneath that the springs mount onto, you do save a lot of weight still, because that spider weighs like 630 grams-ish, usually, depending on what it is. But I figured, hey, why not go for broke? Try using one of the old Mark IIB really thin beds, and then laminate it to carbon fiber. So this bed right here, I used, nope, not E6000. Don't have it in reach. I used high temperature silicone adhesive, which is just silicone in a solvent of some kind. Smeared that on the bed, put some weight on it, and kind of laminated that to the carbon fiber. So this is as thick as that aluminum, but it weighs about 3/4 of a pound less, just to give it a try. Now, the problem was I was depending on the heat deflecting capabilities of the carbon fiber to prevent the heat from soaking through it and into the 3D printed carriage. That did not work. So that's part of the failing of that. And the initial cart just like it melted to goo like on the printer. It was very funny, actually. I laughed. So for the right now, I just have a piece of oak that is insulating, and that worked fine too. But in the future, I'm going to have to redesign that. And then let me see. The last wacky thing is the belt system, the pulley system. So as you can see, hopefully, I think you can see that up there in the picture. This belt system is, there's 3 layers, and it's fixed on the one side. I really hate using, what do you call it, infinite belts or whatever, when you don't have infinite movement. So this is just movement back and forth. So I figured use a block and pulley system. And I looked all over the interwebs for a different one, and I think I saw a block and pulley on like a Z-axis, and then there was one bed by, I forget the guy's, or one printer by, I forget the guy's name, but it was like an Ultimaker clone, and he used a really overly complicated block and pulley system. But anyway, I did that here, and the purpose was so that instead of having to buy infinite belt, you just kind of buy a belt and cut it to whatever length you need, and you could also service that much more easily. You don't have to take anything apart to change the belt. You just unplug the one side and pull it off. And to break up the ringing when you have sudden changes in movements, break it up among the different layers of belts. So these are going to have different elastic responses and different ringing. And what I was hoping was you would get 3 different harmonics of ringing that would sort of cause destructive interference and cancel each other out. So if you did have ripple on sudden jerk movements, instead of hoing, it would be like hoing, and then done. So it might end up looking less objectionable, and excuse me. And that actually worked out pretty well, as I'll show you with some of the prints. Hopefully I'll show you. This is lower resolution stream than I had hoped. So hopefully you'll be able to see the layers on these prints. Let me see. Oh, electronics, yeah. I'll hit on the electronics, and then we'll get into some questions and stuff. That rat's nest down there is just your regular old ramps sandwich. So I wanted to see with this what you could do as far as taking 8-bit electronics and cramming all the new features into it. Because I tried some of the new features with 32-bit stuff, and they weren't all working very well. I later found out that that's a bug that hasn't been fixed yet. But I was after the first iteration of those, they backported it to Marlin 1, and then optimized the machine code and moved that up to Marlin 2 for 8-bit stuff. Excuse me. So you could cram all of those features into that. So I wanted to see, of course, like, since this is a performance per dollar printer, adding firmware features is free. It takes time to tune them in, but you know, if it's a matter of just toggling on a feature and it prints a whole lot better, all the better. So anyway, ramps make a combo. It's a ramps 1.6, just the regular 1.6, and using trinamic drivers on every axis. Try to peek that over there. Maybe you can see the X and a Y. One of them's a physetic, however they want you to say it, clone, and the other is from Vatarot. And those are both TMC 2130s for the X and the Y axis, because I wanted to use sensorless homing, and unfortunately that isn't on the 2208s. But the other axes have 2208s on them. So the extruder is 2208 and the Z-axis is 2208. And the reason for that was when you put this kind of block and pulley belt system on it, it's a 2-to-1 step down ratio. So you have to spit out twice as many steps, but in turn you get twice as much torque, as in holding torque, which is another way that it can help ringing, because when you get to that stop, it's twice as hard to force the motor back a stop, and you don't get skip steps and wacky ringing, things like that. But since I didn't have that on the extruder and I didn't have that on the Z-axis, I figured go with the 2208s and you can get a little bit more current out of them. It seems like a belt pulley would have tensioning and cross-axial alignment issues. Yeah, that's... don't really have those kind of issues, because this right here, I'll loosen up the belt here, is kind of self-aligning. So this isn't rigidly fixed. And then I have 2 millimeters of float on either side of the pulleys on the cart, and you could work it back and forth a couple of times by hand, set the belt in the middle, and it sort of aligns itself automatically. The thing I was concerned about was different step rates per millimeter along the axis because of tangent of just the very slight belt angle here, but it actually doesn't seem to be an issue at all. And looking at some printers like Creality, I think, I don't know, some of them that use the V wheels, they have an extreme angle onto where their belts are stationary, and they don't seem to have any problems with them. So yeah, it didn't seem to be an issue, although I did think that at the beginning. Oh yeah, the motor for the extruder. I wanted to do, because there aren't very many like cantilever type printers that are decent and use a direct drive motor. That was like a Cetus thing, but the Cetus, they print super slow. And so I went to experiment with putting a direct drive on here and seeing how it was. And I figured the belt system would help out a lot. Having the each of the axes mounted very rigidly to the other ones, I figured that would help a lot. But I wanted to experiment with keeping down the weight of the motor. So I started off with various pancake motors and kind of came up with this iteration here. So this was actually, cover that up. This was actually the first one. It was a NEMA 14 pancake motor, and you can see where J-head clone just mounts on there. And I was trying out just a regular like Wade's type gear system. The things that I don't like about the gear system is there's always going to be backlash. The wear is uneven, even if these are prime numbers and not multiples of each other. You still get wacky wear, and hopefully you can see this moving a little bit, because these always print out somewhat eccentrically, so you have to tension it for a looser spot, otherwise it binds up when you get to that spot and you get either surging or skipping when you tension it. So the point of this one was that a spring mounts down here, so this is not rigidly fixed, and then it can just follow along with it, and it's fine. But then I decided to go along with the belted thing, and it kind of killed two birds with one stone. But I did design it so that you can bolt a NEMA 14 on there, or a pancake stepper, and then it's just tensioned by this bolt. So this is only mounted by two bolts, just like this. One is a fulcrum, and the other is kind of free moving, except there's a screw that tensions it. So with my experiments with that little NEMA 14 and the pancake stepper that you would use in like a Titan extruder or something like that, I wanted to see how much torque that would have at the 24 or 26-ish volts that I'm running at with, the trinamic drivers. And it wasn't quite enough to keep up with the top speed of the printer. And I'll get to top speeds in a second. But when you're designing a printer like that, that's one of the considerations. So if this were capping out, if you were to say like, okay, I'm just going to print at like, ANET speeds, or I'm just going to print at like the detailed Prusa speeds or something like that, you're doing perimeters at like 30, inners at like 40, 60, and then your movement speed, like the fast Prusa is like 180, but you could cap it at like 125 and not really lose a whole lot. Those small steppers can keep up with that just fine if you're running them at 24 volts and a decent amount of current. But with this, I wanted to be able to max out the step rate for the X and Y axis and single stepping and have the extruder keep up. So I had to go to a 3-stack NEMA 17 as opposed to the Pancake or the NEMA 14. So anyways, it does work. It only printed, it could hang up to like 90-ish millimeters a second, and then it would start clicking. I'm gonna have a drink here, sorry. Okay. Let me see if the whole world ends if I bring up a browser window. All right, so speaking of like when you're designing around a top speed, this, if you haven't seen it before, is the Prusa RepRap calculator. Did the stream die? Oh, you're lying, you. So anyways, this is the Prusa calculator. So you can put in your step rate up here, and then you put in your belt pitch and your pulley count, and it tells you what steps per millimeter you're going to put into your firmware. So for my purposes, I was using 20-tooth pulleys and quarter stepping, and it's actually, they're 1.8 degree motors, but since we are essentially geared down 2-to-1, where am I? Oops. May not have crashed the stream, but I'm going to crash my browser. Since it's geared down 2-to-1 by the belt system, it's essentially, a 0.9. So that means my steps per millimeter are going to be 40 on the X and the Y axis. Now, if you are or are not familiar with the way that Marlin works with the step rates, they cap it at certain rates, and I'm sorry if this is a review for some people, but you have what's called single stepping up to 10,000 pulses per second. Then it switches to double stepping at 20,000 pulses or up to 20,000 pulses per second, and then quad stepping up to 40,000 pulses per second. I wanted to keep everything single stepping because I was using trinamic drivers. You can get away with other stuff and it just gets a little bit ragged if you're using like standard drivers, but the way that step rate works, thank you for the €2, Jorg. Because of the way that works, single stepping means for each signal you get a pulse. So pulse, 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 pulse. Double stepping, it bunches those up. So if you had 4 pulses, it just goes pulse, 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 and then it skips, or pulse, pulse, and then it skips. Pulse, pulse, and then it skips. And quad stepping, of course, pulse, 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 and then pause for 4. Pulse, 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 and pause for 4. So that it gives the rest of the firmware time to do its, overhead to do its calculations and things like that. But because of the way that the smart stuff inside the trinamics work, yeah, exactly. 4 pulses in a single thing. It bunches them all up. So that's okay if you're essentially like queuing that to your steppers. But trinamics, they look at the space between the steppers before, and it'll see that as an acceleration change. So sometimes when you're using like double stepping and quad stepping, they just go freaking nuts. Sometimes they don't, and it seems unpredictable, but I guess it depends what the pathing is and that sort of thing. So regardless, I want to stay within single stepping just to make sure I didn't freak out the drivers. Let me get all this nonsense off of there. Actually, I need my calculator. So anyways, if my steps per millimeter were 40 and I'm trying to stay under 10,000, It's just 10,000 divided by 40, and that means the maximum speed for the axis is 250 millimeters a second. That's with quad stepping, if you saw me sneak that in there. That's another reason I wanted to use trinamics, because I wanted to be able to maintain a high speed, but still have relatively low volume operation. Wouldn't only 40 microsteps on an extruder produce artifacts? Actually, I'll get to that. For your peace of mind, the X or the Z and the extruder are running at higher native step rates, so they're running at 8. The others are running at quarter stepping, but it's quarter stepping with microplier interpolation. So the way that the trinamics also work is they have a lookup table of pre-computed values of steps, and then it indexes it to a actual step every quarter step, and the rest of them are virtual software steps. So you still get fairly smooth, low noise type of an operation. Whereas if you took like a A4988 and read it in quad stepping, it would be like, it's crazy noisy. So anyway, does it cap your resolution to the single step? No, it's that the drivers don't. It seems to be the way that it works. I read through this a couple times there, Scott, is that regardless of what stepping you pick, it's still using the steps on that table. It'll just additionally pulse on the intermediate steps if you turn it on, and then there's a little bit of extra DSP going on. That could be good or bad, because it does some predictive stuff and it can overshoot. That's one of the things you have to deal with when you're using microplier. Somebody did on reprep.org a big study on like the overshoots, and it didn't seem bad enough to me that it would outweigh the benefits of getting 4 times higher step rate versus like 16 times interpolation. So anyways, did I save my torque curves? Of course I didn't. That would have been smart. Oh, I did. Okay, I'm going to put this big mess of a chart up on the screen. You've seen this before if you watch the videos. Don't worry about reading this. I'll just interpret it for you. So these were, like, rip. Everybody press F for stream. So these were all the various modes of stepping where I went to go and test what the torque was at various voltage ratings, as well as using interpolation and nod. And the highest torque that I had found for these with my macaroni curves was using spread cycle at higher voltage in quarter stepping with microplayer interpolation engaged. So that's why I went ahead and used that for this. But if you want or need to use higher native resolution, you can, and then you'll either just be straying into double or quad stepping, or if you're like, well, I'm designing my own printer, or building my own printer, speccing it with these, and why would I want to move at 250 millimeters a second? 125 times is fine. Then you can use 8 stepping, 8th stepping, 1/8, whatever. And if you are saying, well, that's fine, but I'm using a very small nozzle, I'm going to be printing very slowly, or using a very large nozzle, like let's say you're using a 1 millimeter nozzle, you're not going to be able to squeeze enough plastic out of that to get higher than like 60 millimeters a second. Go ahead and run in 16 times, native steps, and you're not going to be able to get over 60 millimeters a second without, going to double or quad stepping, but you're not going to be running there. Thank you for the F. Inside video game joke for those who don't know. So regardless, what was I even talking about? I tend to ramble. Step rates. Oh yes, stealth chop and all that. So one of the caveats. I should pull up my caveats thing. Is this it? Yeah, so let's talk about, well, let me open the firmware for you, and then I'll go through the features and tell you what was a huge pain in my butt. Alrighty. So this is VS Code Marlin 2.0, and I took, just for ease of use, yeah, definitely. For ease of use, I took all of the features and I stuck them up at the top and commented them out in the middle. So here we have S-curve acceleration, junction deviation, which are in the configuration file, and then linear advance and adaptive step smoothing. Those are really the big ones, in addition to some of the trinamic settings. And I'll talk to you a little bit about the problems that I had with that. So then if you decide to try to do this stuff on your own, you know what you're getting into. So it seems to me that 8-bit with this setup that I had and S-curve acceleration won't work properly in Stealth Chop. And I did not, unfortunately, put like a logic probe on it or anything like that to actually look at the pulses and see what's going on. It could be that they're outrunning the MCU, but it's unlikely. It seems related to something else. But regardless, whenever I turned Stealth Chop on, I got this. Obviously not what you're looking for. With all of those features turned off, it works fine, and certain combinations of them also seem to work fine. So I went through here, and this is a big long list of toggling on and off each of those different things and seeing which ones made a skip and which ones done. Which done isn't a word. Which ones made a skip and which ones were just fine. And it seems to come down to like S-curve is the one that killed it. Let me see if there's any other one. Yeah, Stealth Chop. Yeah, and junction deviation. So since Marlin 2 is a running target, it's tough for me to say like this will work for you now, but it won't work for you in the future, because they could be patching those up, or it could be like the bug with the 32-bit like LPC series chips, where they have some onboard caching features that throw everything off, and then stuff just doesn't work, and they don't fix it for a year and a half. Let me see if I can find some of the other prints. Yeah, as you can see, I started off in Stealth Chop and then toggled it into spread cycle halfway through, and it started printing fine. Mention trying Clipper. Yeah, I stocked up on Raspberry Pi Zeros and the regular Raspberry Pi, so those are all ready to go. One of them actually has Clipper on it already. I'm just too busy to mess around with that too much. So regardless, don't want to get too off track here. Yeah, Stealth Chop seemed to be a little bit weird depending on the features. So the point of this wasn't like ultra silent though. And you'll see when I do a print that it's actually pretty quiet, even with quarter stepping and spread cycle, and with the interpolation at 24 volts. Another problem was, I don't know if you've messed around with linear advanced at all. Sometimes it's called pressure advanced and other things, but it seemed to be sending a whole bunch of random signals to the extruder and making it make a bunch of noise and glitch out, and it just wouldn't print. And I saved the first print I did with that. I don't know if you'll be able to see this or not, but it just looks like fuzzy on the outside. It was a freaking disaster. And that was from everything just being normal and then turning linear advance on and trying to tune it. So I jumped onto the Marlin GitHub. I went to the RepRaps stuff, and it wasn't working right at all. And so then I stumbled across somebody who actually did put a probe on it and saw that the pulses were much faster than one would want. So I went down to Is that an advanced? I went down here to the stepper tuning, and you have a couple different parameters you can set here. One is the delay between step and direct signals, which you require a minimum there. It's in the Trinamic data sheets if you want to look it up. But I set that much higher than necessary. That didn't have too much of an effect, but changing the minimum pulse width did. They Scott at Marlin recommended 2. I just set it up to 4 just for kicksies. But the thing that really helped was limiting the maximum stepper pulse rate. Now, since I was trying to limit everything to single stepping regardless, I don't need a higher pulse rate than 10,000. So as soon as I set that down to 10,000, linear advance behaved itself. So linear advance is engaged, and as long as that maximum stepper pulse rate stays low, it works fine. As soon as I set that up to either uncapped or to the like 50,000, or what do they recommend, 400,000 for the Trinamics, the extruder just it freaks out and it prints out all fuzzy on the edges. So anyway, that's what seemed to do it. So just try that out if you're having trouble. If you had trouble with linear advance and decided to just can it for now, try limiting the pulse rate and see if that works. It worked for me. It's repeatable, and then just raise the stepper pulse rate up to whatever you need. I bumped it up to 20,000 so I could have room for, in case there was some overhead on movements, the 250 millimeter second movements or something like that, and add additional pulses in there that weren't double stepping. So regardless, that seemed to work fine. What other sneaky things that I have to do? Yeah, let's talk about junction deviation. That's something that I really wanted to try, particularly on like a cantilever or something that would traditionally be like a floppy kind of a printer. It takes the traditional jerk value, and as opposed to making it a linear value, it makes it a shape value, I guess. And you tune that coefficient to the ringing on your corners. What's that? I believe there's a known issue if you mix 2130 and 22.8 and you have to lower the pulse cap. Oh, well, there you go. Works for me. I can confirm that issue. So hopefully these show up. Let me bring a light down here. This was no linear advance, and hopefully you can see the ringing on the edges there. This was like no advanced features, and it has that bulging lip around the corners. And then this was after it all got tweaked in, and you can see that's gone. And as far as the ringing, shine that in the light there, you don't have ringing across. I think this is primarily because of the belt system, but you just get one kind of junk and then it's gone, which is preferable to shine it in the light, preferable to that. But that's what your junction deviation is mostly going to do, is to get rid of that bulging right there, as well as your linear advance or pressure advance or whatever, which just kind of pass forward and then tries to equalize the flow of the filament so that you don't get that. Now, if you're using Cura, I think they have a note on this up on the Marlin page. You have to turn off all of the features that kind of try to emulate that in G-code. So you have to turn off coasting and those types of things, because that'll do not really the same thing, but like a dummy version of that, where it just kind of stops extruding and it lets the filament run out over the last part of a move and then primes it to go to another move, because those two will fight with each other and you'll have all kinds of problems. Get this light out of my face. Now, S-curve acceleration. I've read online people messing around with this, having better or worse results. Now, linear advance and junction deviation are not set up, or not, I should say not optimized for S-curve acceleration, but it does seem to work a little bit better, so I just left it toggled on. I wasn't going to say, like, no, don't do that. And where I did really find a big difference on S-curve acceleration is on these types of prints, when you have the kind of infill patterns, or the top fill, toggling that on and off, you don't get that machine gun when you have the S-curve acceleration on. So for me, just that was worth the price of admission, and it didn't seem to hurt the printing in any other places, except that on certain lengths it tended to slow down the printing on the axis. I guess the ramp up time was just, you know, slower than traditional acceleration at the same values, but that's fine. And adaptive step smoothing, that's not something you tune. I think it's just linear interpolation of the step signals and additional pulses at low speeds, like below 1,000 pulses per second. Off the top of my head, I think that's what it does. So it's just when you're doing slow moves across the bed, like homing moves and things like that, it evens it out pretty nicely. So I toggled that on and off. It did seem to make a difference in, like, you know, initial moves and leveling, because it wouldn't go like burp, 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 burp. It was nice and smooth and quiet. So I guess that works fine. There's not really too much to mess around there. Yeah, there is S-curve in Marlin 119, as far as I know. I didn't try one. Initially, I did install 119 on here, and then I was like, well, I will just do everything for version 2, so that way if I decide to unplug the Mega and plug a rearm into there, then I could just toss the same firmware and change the settings in the firmware and not have to worry about redoing everything. And then linear and then linear advance. And I would bring up my browser again. Maybe. You can do it. Okay, linear advance. So, the easiest way to do this is just print out the test pattern, and this is on Marlin's page here. If you go down to Tools, Calibration Pattern, set this all up for your printer, and then you hit Generate G-code, it spits it out here, click Download, and what that does, I think, yeah, they have pictures down here. It just prints this on your bed, and you look for which line is the most even between the slow and the fast moves and that type of thing. It's real simple. It doesn't show it on a picture, but it prints the numbers out next to it, the K value numbers, and then you just stick that into your firmware and then put it into your slicer. Oh, you guys. For some reason, anytime someone posts a link, it holds it for review. Come on, how do I approve those? Well, I won't worry about it for right now. Sorry, I'm trying to bring Cura up here. Oh, Python, you're so slow. Okay, sorry. Linear advance, yeah, it helps by you know, I did a bunch of these tests and I labeled them, and it would have been smart if I had them ready. But I don't, because I'm dumb. Yeah, so think linear advance, it works with just the extruder, and it deals with the pressure on moves where normally it would build up too much and blob out, or it would run out a little bit. So it makes for much cleaner edges, because if you can see, nope, like with the old print where you have the bulging around the edges, and then new print where it's nice and smooth and clean. That also has to do with the junction deviation with the jerk. I mean, they're kind of related, but one is the pathing and the other is just the extruder. But if you tune it incorrectly, the junction deviation, and make the linear advance if you're too conservative on the settings, you'll round those corners off too much. So it does require a little bit of tweaking in. But regardless, I'm going to do... in the coming month, I guess, or a couple weeks, or however, I'm going to break down each of these little things and do spin-off videos that do it in detail. So I'll go over everything. And that is one thing that I noticed, is like they put these features in, and the descriptions on the Marlin website are like you kind of get a little bit of an idea, and maybe you can poke around on some of the forums and see some stuff, but there aren't a whole lot of videos on them. So that was another inspiration behind trying to go ahead and do this series. But here's one of the problems if you have it tuned in too mildly. See, I didn't get a good joint right here on the end. Anyway, Cura. Manage printers. Come on, you can do it. There you go. Oh, I did not add my K factor. I was going to say then you can add your K factor to your start code, but I guess I put it in the firmware instead. But right here we have the mesh leveling stuff, so I'll talk about the mesh bed leveling. Yeah, obviously, since this is not an adjustable bed, it's just as flat as it's going to be. So there is, I can't see my second camera right here, but just the regular inductive sensor on the side. And I used mesh bed leveling, not the UBL, ABL unified step-by-step thing, because I think that kind of makes it a little more complicated than it has to be. But it just does the 9-point test on the bed, and you have a matrix of those points, and you save them into your firmware. So the simplest way that I found to do it is just do the 9-point mesh with your regular settings, and then do an M500, save them in your EEPROM, and then not worry about it. Excuse me. That automatically saves the mesh to slot 1. So if you add in your start G code M420S1, you can't see what I'm... Oh, yeah. I can't see what you're pointing at because I have my printer covered up. I'm just gesturing at the bed of my printer. Yeah, M420S1 will load that mesh from the EEPROM, so you don't have to level it every freaking time. And then right here, this is something that I had to kind of stumble on for myself. Maybe I'm just dumb and everyone knows about this except me. But the fade height, where it will do mesh bed level, or it'll do the Z height measuring variance for X amount of layers, and it'll gradually level it out so that you're not doing any compensation on the Z anymore. And that's something I found because I was like, well, you know, I have this set up, you know what the magic numbers are, the full stop divisions of your Z axis. Well, I had to set up mine as like 0.04, and obviously when you're doing mesh corrections or baby stepping or something like that, then gee goes blaze it, you get a you made me lose my train of thought. You're going to lose those magic numbers. So what this does is it gradually evens it out to your magic numbers of your layer heights that you set in your slicer. So that's just what this is, your 420 Z1, and then you just set that in whatever your fade height is. I have it set to 1 millimeter. It's all good. Let me see what I may have missed. Too many notes. Let me see. I'm looking at, I have notes, good stuff and bad stuff. I'm looking through the bad stuff to make sure there's nothing else wacky going on. Oh yeah, here's something. I did not do enough testing to track down what this was, but I had, let me pull this stupid firmware down so you can see me pointing at the printer, and I don't need a calculator anymore. Anyway, I had 30 tooth pulleys on the X and Y axis, and I had 20 tooth pulleys on, I'm sorry, 30 tooth on the X axis and 20 tooth on the Y axis. And a lot of these things, the features just weren't working right. It was going all freaking goofy. As soon as I switched out to 20 and 20, it got beautiful. So I didn't do enough testing to file a bug report. I don't know if that had to do with the step smoothing or the S-curve, S-ramp generation, whatever that is. But for some reason, that math was wacky. I suspect it may have also been that when you have to enter these firmware steps in, this was 40 because it was a nice even integer. This was 26.266666 repeated, and that just didn't work right. As soon as I changed it to an integer, it was fine. So I know that 8-bit processors are not great with floats and doubles. That flipped it to a double. As soon as I turned them both to ints, that was fine, but they were also both even numbers, so it could have just been an interpolation thing, and then it was fine. Or a rounding error. I didn't track through with all the math to see where it truncates and if it's using, floor ceiling function. And I don't think that, well, I'm not compiling with Arduino. Platform IO and VS Code, I don't know if they're using the standard C math libraries or not, so I would have no idea where the floor ceiling and truncate functions go. I would have to actually run those tests. And life is too short. All I know is when I changed it to integers, it was fine. So bear that in mind. Let me see. What other problems? Y-axis hits resonance at unfortunate times, but does not stall. Okay, what I mean by that is the Y-axis bed, since this was very lightweight, it did push the midband resonance into an area that was awkward, and so it would be very rough action when I was printing. Where did that swirly vase go? Like when I was printing this, it would hit some speeds around here where the Y-axis was, it sounded very loud and grindy. It ended up, it was just the linear rail that did not have any pretension rattling around ever so slightly. As soon as I put a little stabilizing wheel on the side, that went away. So yeah, just something to bear in mind with the cheap rail. It sounded to me like when it was happening, it sounded like when your stepper is grinding, but it wasn't a stepper at all. It was just resonance. So I found that out when I just put slight pressure on the side, and it would go away, and then fix the problem with the wheel. Okay, let me see what else. Junction deviation is not optimized for S-curve acceleration, yet it works. I mentioned that. Oh, hybrid stealth spread doesn't work right. Yeah, this was a weird one. And I don't know which of these features it was, but it's another thing to keep in mind with Trinamics. If you know, you can go into your firmware and set hybrid mode. So if you're below a certain speed, it'll work in stealth chop. If you're above a certain speed, it'll work in spread cycle. For some reason, if I went onto the LCD and toggled back and forth between stealth and spread, it was fine. But using Marlin's built-in automatic switching hybrid mode between the two, when it switched from stealth to spread cycle, it was like really loud and grindy and a mess. And I looked on the Marlin forums, and other people have, did I say Marlin right? Yeah. I'm a guitar player, so sometimes when I say Marlin, or think Marlin, I say Martin, but whatever. Marlin went on the Marlin forums, and other people were having problems with that as well. And so it's a known issue, but it's one of those, like, who knows what's causing it. So I turned hybrid mode off. Where did you put the wheel exactly and how? I may have heard some rattle too at some speeds. Maybe I could, let me pull up a CAD. First one, Martin Guitars. LiveStream printer. Is that it? Yeah, that's it. Let's open good old 123D and I'll show you where the wheels are, because that would be easier than me flipping this around. Slow loading, but even slow loading CAD is faster than Cura. Imagine that. Alrighty, this is old ass software. Can I say ass on a live stream? It's old software. Forget that I said it. Anyways, yeah, if you're unfamiliar with 123D, it was the freeware software before Fusion 360, but it's direct solid modeling as opposed to like quasi history based parametric. What's it that Fusion 360 is? I like 360 for very prescribed things, but for just like playing with shapes and stuff like that, I'll use 123D or other direct solid modeling. My first CAD class was 1995, 1996 or something like that, like freshman year of college, and we learned direct solid modeling on silver screen and then did like some AutoCAD stuff. So I just got used to sort of like messing around with it. DSM is a feature locked version. Yeah, there's a quasi DSM in Fusion 360. They call it like history list mode, but you still have to use their dumb like right click toggle radius pull down menu thing, and it's annoying. I like this much better, where you just like start with a drop a primitive and then move it around, just for like knocking out things like this. But anyway, so here's the cart, if you could see that. And so there was some play between that and this side of the rail. So these were the wheels that I set on the side of the V-slot that was already there, and then I just made this to bolt onto the bottom of the cart. And through these slots on the side, I had just a bolt running through this slot on the side and an embedded nut right here that could apply pressure against the side, and that pulls the bearings on this side flush against this part of the rail, and then it doesn't anymore. So yeah. No, I do not want to save my work. Thank you for asking. You can close down now though, and please not crash my desktop. Oh, Space Claim. Yeah, I haven't tried Space Claim. Yeah, so with the linear rails, like I said, there's good and there's bad. I would like to try the pre-tensioned ones because those might not rattle. It's really like it didn't seem to be a whole lot of ringing that was caused by it, except with the extruder that had a lot of lateral play on the cornering, which is why I had to add the wheel in the back of that one. I only have one wheel on this one and it works fine. But if you had a pre-tensioned one that didn't knock around like that, they'd probably be fine. So I'll have to get one of those in and see how it works. And like I said, the Z-axis, which was a slightly more expensive one, that worked fine too. And that was even with replacing the bearings with the larger ones. I left one of these, I think it's this one with the O on it, with the original bearings, and this knocks around quite a bit more. So it definitely helps to put the larger bearings in there and to put the grease on. But did you use a single MGN12 on the X, by the way? Yeah, it's a single one of the minis. It's the whole thing. This extruder's just bolted right into. You know what? Back to CAD. I should have done this at the beginning. Nope, that's not it. That's an ancient extruder. dear Lord. Going through my entire CAD library here. All right. Yeah, the extruder is just mounted to the cart right back here. Just a single cart, and it works fine. And then this was the these are the pulleys for the belt, and then I just bolted a single wheel here, and that just pre-tensions it. Really, all that wheel is just pre-tension, and you know, it might not be necessary if it's pre-tension. Oh yeah, and here's this shows the second cart up here if you don't like the cantilever design. The only reason I didn't do that for the live stream was because it pushes the bed 20 millimeters forward, and I would have lost 20 millimeters of bed space. You gonna ask if I want to save it? Okay, there we go. Okay, let me answer some questions real quick that are popping up here. Did you use M3 nuts, square nuts, or brass inserts? I used the M3 square nuts because they're easiest to model for, because they're just they're 5.75 by 5.75 by 2.73. I've typed that in so many times in the last few days that I have that memorized. So I just do like 6 by 6 by 3, and I use that embedded. It just makes it easier. Plus, they're silly cheap. I didn't use any embedded. Well, I used some for the bed. I used embedded brass nuts. For the rest of this, like, these are just fine pitch wood screws right into the like, I make a very thin, like a pilot hole, like 1 millimeter diameter, and then use wood screws through it. And something like this I put a slot for an embedded nut in there, but this for right now is just threaded machine screw right into the plastic, and it's fine. Yeah. Why do they sometimes put copper shims under linear rails? I don't know. I don't think that I've seen that. That's weird. Tramming? Question mark? Yes. Or auto bed leveling, or whatever you want to call it. Lewd gestures on cameras. That's me. Copper strip. It was a single copper strip underneath the entire length of the linear rail. Probably just a shim then. Are the V wheels original open builds V wheels, or doesn't it matter anyway? I have both. Where is my wheel box? Like, these are just AliExpress jobbies, and then I have bags and bags of like original open build stuff. I tried 3D printing these, but they're never exactly circular, which is unfortunate. And then generic bearings. The bearings you get from open builds, and the I'm staring up at the monitor instead of the camera. The bearings you get from open builds and the wheels they're much better, but as far as the wheels themselves, as long as you get them properly turned out of Delrin or Palm, the import wheels are okay. The tolerance was a little bit looser, but it doesn't seem to matter after they wear in a little bit. However, I still mostly order them from open builds because they're right there. They're across the river, so they're pretty close. And like I said, their bearings are a lot better. This one has the cheap bearings in it, and they bind up so much. Even if you put a shim in the middle, they still bind up. They're really junky. Okay, let me see if I can finish up the bad stuff, and then we'll get on to something else. Stealth, hybrid, doesn't work. Medium extruder. Oh yeah, this is the last thing. So that's one of the reasons I went with, usually for experimenting, I'll just do like the ramp sandwich type deal. But I like that you can pop it out and pop 32-bit stuff in, so you can compare features back and forth between them. On the anything that derives from Smoothie uses the LPC series 32-bit chips, and I mentioned this briefly a little while ago, that some of the features don't work so well with those because of a bug. And I tried different combinations myself to see what would and what would not work. And nope, that's not the thread. And I couldn't quite track it down. But if you go to this page, this fellow, under issues on Marlin, problem printing when combining certain options. He had a problem with the MKS S-Base, which uses the LPC series processors, where all of these various features, he was getting like Leaning Tower of Pisa type shifts when he got it. So if you're going to switch to like a rearm, or you're using an MKS or anything that uses an LPC, I think the Big Tree Tech SKR uses it, and that type of stuff. Yeah, check out that thread. I don't know if that's a bug that's going to be fixed or not, but unfortunately I couldn't pop a rearm in and test these as well, because that uses an LPC series chip, which hopefully that can be solved in the future. Any non-US merchants for quality V wheels? I think there were German distributors of genuine open build stuff. I don't remember which site though. I just kind of stumbled across it when I was looking something. And they may be still selling on Amazon. I'm not positive. I think their stuff was up and then maybe got pulled down. Oh, there you go. Retrig.com. Yeah, and I really like the open builds, like all their stuff pretty much. I mean, all this V-rail came from there. The pulleys came from there. The belt came from there, all that stuff. I actually have, I had Gates belt on order for this, because this is like this is from like Big Tree Tech, I think, just off of Amazon, and I wanted to do whether it's worth it to move up to Gates belt as opposed to Big Tree Tech, and if you had to use like special pulleys for it. But it hasn't gotten here, so who knows when that'll show up. I was fully expecting for it to show up this morning, and then I'd be in a super rush to try to get the tests out for you all, but didn't show up. So all right, so why don't I just open up for some random questions now about what I may have talked about. So if any of you want, if I, in my blabbing, you were like, wait, you totally missed something, just you can ask me here, and then we can print a thing or mess around with some firmware options or whatever. This is mostly for the benefit of you all, since this is not going to be a build video. But let me just start a print in the background, and we'll see what I have on this card, just for funsies. I'm going to start this up so you can see what spread cycle quarter stepping with interpolation sounds like. So I'll just let it heat up. Oh, and it's a ridiculously high current. I don't know if you can, you can't see how fast that nozzle's shooting up. This was a 60-watt heater for the nozzle, but I'm overvolting it slightly, so it's actually running at 85 watts on a volcano. I'll point the mic over there so you can see what this sounds like. Oh, are you hearing that pulsing? Wait till this goes to a fast layer, and then I'll put the microphone back where it belongs. There you go. That should be 100 millimeters a second with, I forget what the acceleration was, I think 3K. And that's stump chop at 26 volts. Or not self chop, spread cycle with 26 volts, quarter second, and the circulation. That's not even close. Fan OP, yeah. It's the fan is what most of the noise is. I'll stick it right up on the motor. And it's really not loud at all. Sorry for the thump here. Rest in peace, your ears. Okay. And you probably can't even hear that in the background. It's still pretty quiet as long as you have the interpolation engaged. All right. I had problems with retractions when I had a volcano. Any tips? It depends on the size of the nozzle you're using. Now this is a standard volcano, but I'm just using a 0.4 millimeter nozzle on it, so that I can get up to a higher print speed without running out of juice. But if you have like the 0.6 like I have on my testbed printer, or like the 0.8 or even larger than that, you're going to have problems with oozing. You're going to have problems with, and we're finished already. You're going to have problems with your retraction. So what you want to try doing is, I don't know what kind of printer you have, but you want to retract quickly and then do your retraction prime more slowly and see if that works out. That worked out for me. Alrighty. Wow, that's fast. Yeah, that's not as fast as it can go. Like I said, it's set for 250 or 250 max. So this is how it turned out at 100 millimeters a second. That's 3K acceleration. And with all those advanced features, you can see I'm trying to shine it in the light. There's no ringing on the corners. We don't have any bulge here, which is nice, and that's from tuning in the linear advance and junction deviation. What speeds for retract? On that printer, I had to, for the large nozzles, I had to go as fast as I could on the retract without skipping, so you may have to test it out. But I was doing 60 and then like 30, or 60 and 20. This one is 40 and 30 because I'm using a smaller nozzle, and that seems to be enough. Some of those advanced features, they kind of seem to make as much or equal amounts of retract unnecessary. You can get away with less retract. Fast acceleration does suck some filament back. Yeah, it seems to. I think in the Marlin Prusa, or the Prusa Marlin edition, whatever, the Prusa firmware, I think they have compensation for that. It's like lost filament compensation or something. If anybody is a Prusa owner, you can let me know. But yeah, I don't recall that being in standard Marlin, but it is a tunable parameter for the Prusa version. Let me see. Yeah, more about the volcano. Yeah, that is one of the things that I'm actually liking about the advanced setting is since it doesn't need as much retraction, you can get away with a volcano a little easier. And I really love the volcanoes because they can put out so much more filament without under extruding or clicking or things like that. And this, I specifically designed this and that goofy geared extruder that I misplaced already to use a standard J-head clone. So, whoops. So these are just the cheapies you get off of like Amazon or whatever. That's also a cheapie off of Amazon. Can I explain the extruder? Yeah, it's a 3-to-1 ratio belted extruder. So it's ugly. It's the pre-beta version. It was just something that I threw together because I wanted to have a belted extruder that works pretty easily. But yeah, let me see. Let me print something fast. Are you going to post this printer on Thingiverse? I want to post it somewhere. Like, I've tried a couple other. If anyone has suggestions, let me know. A couple of those hosting sites, and either their interface is goofy or their search is goofy. Not that Thingiverse's search is great. Um, so I might just continue using Thingiverse. Um, I can go ahead and post the STLs. I would definitely have to clean some things up, and I do things for like when I'm considering like a pre-beta or a proof of concept type of a thing. Um, I do things like using wood screws everywhere instead of using like proper inserts or redesigning so that don't need that type of thing. So I would have to do a redesign, but if there's interest, I'll post them up, and then there aren't too many printed parts, so it is something you could just try, and then if you don't like it, build something else. But yeah, I'll definitely put the extruder up there as well. Yeah, VD, I guess I could use GitHub. I actually, when GitHub sold to Microsoft, I pulled all my GitHub stuff down. There might be like one project file up there now, but maybe I could use GitHub. What else we got? I blew the voltage regulator on my Arduino a bit back, and the USB provides the 5 volts currently. Should I remove D1 from the ramps board and give it an external voltage regulator? Rich, the way that I have mine set up is, if you can see, this USB cable back here is powering the ramps board, and I have D1 removed. So I just use, I mean, obviously I'm in, well, not obviously, you didn't see it. I'm in Pronterface. There we go. But when I'm not in Pronterface, I just use a powered hub. It's buried back there, so I can't grab it. So then just use USB for the whole thing. Doesn't the weight of the extruder add ghosting at higher accelerations? How about flying extruder like in a Delta? Yeah, there was a printer. Can I reach it? Maybe. That I was working on that I wanted to try a. Oh, okay, I'll grab it down. I don't know if this will fit in frame. Like future design, this was a cross gantry, and I was going to have a separate flying extruder up top, but never got around to finishing it. So I may finish that one of these days and use that for one of the other videos. How is the print bed attached to the linear rail? Whew. That's a little quirky thing that I will have to make a better version of before I print any STLs, because the print bed is glued to carbon fiber, and then I have blind nuts through the carbon fiber that then bolt into a 3D printed carriage, and then that rides on the linear rail carriage. I don't know if that's asking too much for like a DIY printer or not, but and that was a slightly faster ringing test. That's not terribly exciting. Let me see if I have something more fun. I don't know the foggiest notion what this print is, so that'll be fun. Let me see. Put it on GitHub, that way people can send PRs to help improve the documentation and clean up stuff for you. Yeah, that's probably the best way to do it. I mean, there's really no collaborative work on Thingiverse at all. I'm hoping this was sliced for this printer, otherwise we might have a very interesting gymnastics display back there. Are you using one of the chopper presets, or did you define your own? Good question. I forgot to talk about that. Yeah, I'm using the... for those who don't know what you're talking about, I will find it and then pull it up so I'm not covering up the printer. I think this is set... I think this is set at... No, that's 100 millimeters a second. That's not terribly exciting. I'll do a faster print in a second. Configuration advanced. Chopper, where are we? Yeah, I'll put this in front of my face so I'm not covering the printer. You can see me a little bit. Anyway, if you go to Configuration Advanced in Marlin and you go down here, this section is the chopper settings. I use the default 24 volt settings, and they tweaked those. I guess I can get that out of my face now. They tweaked those from a few months ago, I think, and they work a lot better, so that the steppers work a lot cooler and they're much more well behaved. Yeah, I know, I'm sorry, covering half the printer. Let me see what else. 10-minute benchy. I did a 28-minute benchy at 0.2 layer height, so that wasn't too bad. What is a print bed surface? The print bed surface... This was something that I kind of gave up on the experimentation because I ran out of time as well. But I wanted to do like cheapy removable printer. So this is not spring temper steel. This is just regular galvanized steel. And I wanted to see how well that did with just regular magnet. This is just standard refrigerator magnet. So it's not high temperature. It'll do up to like 80 C. But it's super cheap. I bought an entire roll of this for like under $10. And by an entire roll, I mean an entire roll. Here's the biggest magnet you've ever seen. But anyways, as far as what the print surface is, it's this. This is just PEI. Please link that when you upload this. Yeah, I got it from a craft supply store, so I don't know if you can get it online because it's a local place. I think it was Dick Blick. But, Oh, this model that's printing is one of the variable models, so I'm not positive what I'm changing on each of these layers. So it'll be interesting to see what comes off when I peel that up. Yeah, so usually there are a couple different types of these sheets. Like if you get this from like Amazon or something, you could probably get this for like Dickflicks. Okay, yeah. So if you could get, you can get this from Amazon for like $10 or $15 or something like that, and it comes with the 3M tape on the back already, so that can save you some trouble. Um, but this, I think I may have gotten this from Dick Blick also, or Pearl Arts or something like that, but it was like $2. And usually when it's optically clear, if it says like optically clear or crystal clear, like it's PEI. Otherwise, it's not. It's like polycarbonate or like the opaque stuff. But unfortunately, I didn't get to time to do this. So yeah, that's just PEI stuck on there. What else do we have? The file you made and showed in the video. Will you share it? Yeah, I think that's this one. Yeah, I can post that. Just looking through to see if I missed anything else. Hey, Dimitri. See you later, Adverse Effects. Thanks for staying up. Got a little bit left on that. Let me see. Glad to hear this presets work better. I spent a night or two scoping out the chopper frequencies when I went to define the new presets. Yeah, they do work better. Actually, some of the guys over at Clipper have worked a little bit more with tweaking the settings, and the Marlin settings now are close to what they came to as like kind of the best bang for the buck settings, and that was pretty close to like what I was feeding in the advanced options for the Trinamic driver. So it seems like as time is going by, they're getting much more tweaked in. 3:30 a.m. Oi. Do you print PLA? Yeah, I mostly only print PLA. I guess I could talk about that a little. I have a spool of ABS that's probably 2 years old or something. That's the last time I printed with ABS. I really don't like... I like the fact that PLA is a bioplastic and it's compostable and biodegradable and all that kind of stuff. I just feel really guilty pumping, complex polychain, non-biodegradable or slowly biodegradable plastics out into the world just for my silly experiments. So for prototyping stuff, I was just using a lot of PLA and I got used to it. That's why I had the series on different methods of heat treating and like tempering PLA, because I was like, if I could get this stuff like a little stiffer, a little stronger, like I could use it for more things, and that actually works. This, if you'll notice, this motor is mounted directly to a PLA printed part. I annealed that in boiling water, so that's why that's not melting to slag touching the motor. It's spaced off by a couple washers too, which seems good. But it's same with the x-axis and the... By the way, I'm pushing these axes around because I have the protector, the diode protectors on there. Otherwise don't do that. But yeah, so these are all mounted as well. These are all annealed in hot water. So this was what I just printed. Having a real hard time focusing on that, aren't you, buddy? Looks pretty good. Yeah, that was the shape that I had showed in the video. That just had all little curves on it. Because I wanted to have the kind of like rumple section, and this is like a double... This move right here, back when they were having problems with layer shifts with Trinamics, this would like for sure send it layer shifting. So I know that if it's printing that okay, then like the chopper's dialed in well, there's enough torque on the motors and that type of thing. And then nice sharp edges where it's supposed to be, nice round edges where it's supposed to be. These little scoops turned out pretty well, and you can see all the dividing lines between the different sections. Rumpelstiltskin, your face is in the pic. What? Anil PLA say it's one of the 3 stiffest materials available. Yeah, it's pretty stiff. CNC Kitchen does. Yeah, I like that channel. He's a good kid. So all the motors are Nemert 17 now. Any numbers on nanometer? Yeah, let me pull up the documentation and see if I have exactly what they are. Alrighty. I don't know if you can read that or not, so I'll read it out to you. So for the question on the torque rating of these motors, the axes are, and these were, I think these were all, yeah, these were all Ziltech, or they have the same versions from Stepper Online. If you never seen Stepper Online, that's a great place for steppers. It's just takes a while to get there, and sometimes you can find them cheaper in like 3 packs on Amazon or eBay. But anywho's, yeah, each of the axes, these are the 1.7 amp steppers, and then the extruder was this guy. So 59, but I'm not running them. Thanks for the super chat, Michael. But I'm not running them at full torque because the Trinamics can't get a 1.7 amp stepper really cooking. So you're not going to hit that 85 ounce torque number. It's more like 50 something. Those numbers are linear. So if you're saying, and Trinamics are weird because you tune them to RMS value instead of peak value. And if you've worked with electricity, RMS and peak, if you're going from RMS to peak, you multiply by 1.41425. And then if you're going the other way, it's 0.707, whatever, 1. But we just say 0.7. So you would be setting, excuse me, 1.7 to RMS is 1.19, and we're going to go for, we usually run at like 85% to leave a little bit of thermal headroom too. So for 1.7, 0.85 times 0.7, then you're going to want to run those 1.7s at around 1 amp. But I don't have them cooking that much. I have them cooking at 800 milliamps. So we're actually losing 20% of our torque. So if our extruder is 59.59 times 0.8, it's actually, yeah, in the 40s. And then down here, these were the pancake steppers that I tried out for the extruder originally, and I made a note for myself here, not strong enough for more than 90 millimeters a second, because that's about as much as I can get from it. There are steppers that have a maximum working current of 0.9 amps. You can get them from Stepper Online. They don't have them on Amazon. They don't have them on eBay. And I didn't special order them because I wanted to use really common steppers for this and see how it tuned in. But you can get more bang for the buck out of your Trinamics there. If you look here, I have, this says efficiency ounce per amp. All I did was I took the output and the current and divided. So the higher that number, the more efficient the extruder is. And it's, it's a subjective ratio, but it lets you compare one to the other. Now that's going to correspond roughly to the balance of your voltage and your inductance. The inductance, however, you can get a whole lot of torque per amp, I guess, a high efficiency rating if you have higher inductance. But the higher your inductance is, the lower top speed you're going to have, because as you are turning faster, you're pulling more, or you're generating more back EMF that's cutting into your headroom, and it's limiting your top speed for your motors. So it's really a balancing act, and that's why I did those, torque performance curves, just to see what was best. Since these are geared down 2-to-1 and I had to do increased step rate, I went with lower inductance motors as opposed to the higher torque at lower current motors, as kind of, the lesser of the two evils, I guess. And these have more than enough torque to deal with it. You get higher torque at higher voltage, right? Correct. Up to a certain point, related to the operating voltage of your motor and the inductance. So there will come a point where you can't raise it anymore with respect to a high inductance motor. But a lot of the motors that we have these days, they're like single digits inductance, millihenry. So it'll be like, 4 or 5 millihenries. But if you have like a 17, 19 millihenry, you're still going to benefit from higher voltage, but you're never going to reach those higher top speeds. You will, however, have higher low-end torque, which is nice. What brand of PLA are you using? I am using Atomic Filament PLA. The color is dark cherry red, and I really like. This is the first time I've used their filament. I figured I would do something special for the stream, because usually I print in primary color, so I wanted something that popped. Not thinking, hey, you're a moron, and it's going to blend in with your stupid curtains, but if I stand in front of it, it looks okay. So anyway, it's a pretty nice color. And I checked the... this is actually... Last night was the first time I printed with it. Where are my calipers? There they are. Yeah, so I always check the filament diameter, and theirs was spot on. Oops. Yeah, so pretty darn good. Almost exactly 1.74. It was a little bit pricey, but it's pretty nice. Sponsor me. I'm selling your stupid filament if you're watching this, which you're not. You're blocking the printer again? Yeah, that's what I do. Do you use Inland brand from Micro Center? I did in the past. It's unpredictable. I think it's 0.05 millimeter tolerance. I think it's like a rather loose tolerance. It's nice and cheap, and it's nice because Micro Centers, like everyone has a Micro Center near them, but it seemed to be unpredictable whether it was going to be too thin or too fat. So as long as you measure it first and then go tweak that value into your firmware, it's all right. And a lot of filaments, they're getting, as far as tolerance, they're getting a lot better these days. It's not like a few years back where you could literally have one part that was under extruding and then another section of the filament where it's just jamming your freaking printer. So yeah, I typically use whatever's cheap. I've been using this stuff a lot lately, which I just get off Amazon, because the black, and I think this actually might be rebranded Inland filament. It looks like their spool, but their natural was like $17, and then the black was like $15. So yeah, I'm not usually super no Micro Center near me in Switzerland. Sorry, but you get to live in Switzerland, so it's a trade-off. I live in Philadelphia and dodge bullets. But yeah, the atomic filament's pretty nice for the price. Have you tried Prusament? No, I haven't. I was thinking about it. I actually went onto the Prusa website and they were back ordered. That was a while ago when I was first thinking about this stream. That was the Inland ABS. I haven't tried the Inland ABS. Actually, I might have some right up there. Excuse me. No, that's mono price. My bad. Might be the same thing. Let me see. Other questions? No Micro Center in Florida. I haven't been to Florida in a while. Let me see. I buy the spoolless Solitech for $12, I think. Yeah, there was actually I made a video on that. I make a lot of videos that I watch and then I don't think they're good enough and I don't post them, which is a habit that I have to get out of because I don't post a lot of videos every day. But I ordered one of the Solidec rolls and it was like 12 something and I was like, "Oh wow, that's super cheap. I'm going to grab a couple of these." Excuse me. And they were the spoolless ones and I didn't have a master spool printed out and I was completely out of filament and couldn't print a master spool, so I had to take a hacksaw to like an old spool and then put the Solitech filament on it and then crazy glue it together and then print myself a master spool and then put the second stuff on the master spool. Yeah, that's what happens when you don't pay attention. Let me see. Prusament PETG is the best PETG I've ever tried. Yeah, I'd like to give their stuff a try. Is your board already 32-bit? No, this is an 8-bit board. So that was, I know you showed up a little bit late, but that was part of the kind of design process around this was using 8-bit with the advanced features to see what we can milk out of it and getting away with that because we were using, what do you call them, trinamic drivers that I could run at quarter stepping and not run out of gas with high-speed prints. And again, I'm going to make instructional videos for all of these as in the coming weeks, so that's what I'm going to be working on next. Let me see. Make a beat channel for videos you don't think are good enough. Yeah, maybe I could do that. Yeah, like I don't. If you're watching me for a while, you know that there was a period of like 2 weeks, a few months ago, that I didn't post anything because I was compiling extruder math, and I just did tons and tons of extruder math and all the geometry involved and things like that, and went on this 2.5 hour rant. Tried to cut it was actually longer than I cut it down to 2.5 hours, and then I cut it down from 2.5 hours to 1 hour and 45 minutes, and then I was like, well, I need to break this up into sections because I can't post like a 2-hour video where I'm literally just talking math at a camera for 2 hours. But there weren't convenient breaking points, so that was like 2 weeks of work where I was like, oh, this stupid video, I'll come back to it later. So I will be doing an extruder math series, but I'm gonna have to plan ahead and not just talk numbers at a camera for 2 hours. Didn't Prusa sell Prusament via Amazon US? I don't know. Do they, Pauline? I'll have to check. I didn't even think to look. Actually, I didn't know Prusa was on Amazon. Oh yeah, but about the 32-bit stuff, that was part of why I wanted to do the Ramps Mega Sandwich, because you can just plug a rearm into there. And it would have been nice to do the A-B between the 32-bit and the 8-bit, but a lot of these features, if you look at that Marlin GitHub thread that I posted with the advanced features, toggling them on and off, and they weren't working. Unfortunately, I couldn't just keep that the same and plug a rearm in there because the LPC chips have that bug in Marlin. And man, let me just complain for a second about that. So I still have my other printer over there, the one that's usually in the videos. That's 32-bit right now. And I have all the advanced features turned off except for, I think, S-curve acceleration. And I didn't know that bug was still active. It had just like popped out of my brain. So I tore that thing apart twice. I ordered a new Z-screw. I changed the motors. I reprinted the Y-axis carriage. and then stumbled across that thread on GitHub, and they were like, "Oh yeah, everything's prints slightly tilted if you enable these features," and I was like, "Ah." So anyway, look first, act second, I guess. All right, let me see what else. I should be printing something while I'm talking just for fun. I'm terrible at this. Let me print this vase. Let me see. Did you already tune in the acceleration and talk about it? And what do you look for, like ghosting and quarter angles? Yeah, that was some of these prints. So you can see this is like hard square prints to really tweak that in. And then I wanted to see what was going on with the ringing on the sides. So this was, what did I say when I printed out? Well, I know this was 100 millimeters a second with 3K acceleration, and I think this varied, but it was already fairly tuned in. So this was probably printed at the Prusa Mark III optimal settings ×2. So they set their outer shell acceleration at 800 millimeters a second. So this will be 1600 millimeters a second. That's yeah, cubed. Sorry for acceleration, which is pretty slow, but that's pretty fast for a cantilevered printer. So this is about twice that, and you can see it's still pretty good. I'll post better pictures in the video when I put them up. I'm just going to turn up the heat on this nozzle a little bit because I'm not re-leveling the bed. So it's going to be a little, and I don't want it to pop off. I guess I could level the bed, but whatever. Let me see. Looking forward to extruder math. Yeah, I have to get that up. Tried a few versions of flexible shaft and worm gear extruders and didn't like the results. Yeah, I thought about trying those too. It's just you need, it's usually those worm gears are like 40-to-1 reduction, which is just crazy. Is that sticking? It's not even printing. Alright, I'll just let it go. Yeah, those worm gear drives. I thought about like trying out some of the Dremel drives and things like that. They had a lot of play in them, so I was like, well, what's the point if it adds backlash and that type of thing? What else? This is around the same time I discovered TMC 2208 Stealth Chop doesn't like sudden speed and direction changes. Yeah, unfortunately that's true. The 2208s use Stealth Chop 2, and there is in addition to the PWM voltage regulator, it has a pre-regulator. So it, like, overall, it Stealth Chops better than Stealth Chop 1, but it seems to be thrown off more by sudden changes in, like, acceleration, that type of thing. I would like to try all of that with, like, junction deviation as well and see how that is, but I know that it's really goofy with, like, linear advance. So, another thing to try in the future. What does a motor's protection look like? I have one right here. Focus, Daniel-san. Here you go. It's just one of the step stick protectors. And these are all diodes on the board, and they clamp the output to the rails. So it clamps your output to ground and then whatever your V plus is. This is also very nice because if you're running trinamic drivers right up around their limit, even if you're not thermally throttling, because of that back EMF, you can get overcurrent warnings that trigger the chip to, it's basically on the same mechanism as like ground fault and thermal warnings, and so it temporarily shuts the chip down until a particular number of cycles go through and it doesn't see a fault. But that's like really fast, like microseconds fast. So it manifests itself in when you go around a corner and it hits an overcurrent, shuts off just for nanoseconds, and you shift over and then it turns on. So the layer shifts aren't from like not enough torque or from thermal shutdown. It's just from that back EMF making it, shift the layer essentially on a corner, and this helps with that by clamping the voltage. So, and that's a test you can do yourself very easily if you feel like possibly accidentally blowing up the dynamic, which I have for the sake of science. Let me see if this will be happy faster. This is at 60. Let's take it up to 100. And again, for you, those of you who didn't get the microphone thing, let me point this over. So headphone warning, 3, 2, 1. And I'll go over here because this is a hypercardioid mic. This is running in spread cycle mode, quarter stepping with interpolation on, and you can hear it's still pretty quiet. Not even as loud as the fans. So I'll shut up for a second so you can listen. Headphone warning, 3, 2, 1. Alright. Let me turn this up faster. So it's 66, 7, 8, 9, 2. See how that behaves. That's 125. All right, let's check these questions. When changing from V6 to the Volcano, is there anything you always change? Not sure what you mean by that. Yeah, you mean as far as parts, or me personally? You have to do, well, obviously the block, and then the cartridge, and the nozzle. Everything else should fit. The heat break should fit fine, and the body should fit fine. And I said earlier, I don't know who was here or not, this is just a J clone off of Amazon. It was like 18 bucks or something like that. It does have the E3D genuine sock on it, and that's wrapped with some fiberglass tape just to keep it from melting the fans, because I have to redo the model and move those out a little bit. Bump the speed up a little more. Actually, let me bump the acceleration up, because I think we might be throttling there. Well, I bumped the acceleration up and it didn't change, so that means we are not throttling from the acceleration, so I'll bump the speed up. Math is hard. 6, 12, 18. 6, 12. Bump this up 250%. Let me see if I can make it skip a layer. It's doing all right for now. Okay, let's see. My 22.8 arrived this week. We'll see. Had 8825 with no problem. Will be interesting to get the Trinamic going. Yeah, my default when I don't feel like messing with anything, it's just the old Texas Instruments ones. The only problem with them is they have a little bit of, more pattern because of the decay mode switching. All drivers do decay mode switching, at least all modern ones do, but the TI ones are a little bit sloppy, so that's why people use the smoother diodes and that sort of thing. Alright, Claus, we'll see you later, man. I'm going to wrap this up here soon. I just want to let this print a little bit more. Oh no, Björg. I'll repost the stream on the YouTube channel so you can catch up, and then you can skip me saying stupid things. I'm going to keep increasing the speed until something goofy happens. So this is 6, 12, 6, 12, 18. Alright, that was originally at 60. I turned it up 363%. I think we're getting capped off by the 2-second layer time, unfortunately, so I think that's as fast as it's going to go. Did you ever use the heat tower for finding the right temperature for the new filament? Yeah, definitely. You can do that with the video that I posted before this, kind of the preview of the stream or whatever I called it, with the Tweak It Z plugin for Cura, where you can change the nozzle and everything at particular heights, or just have it pause at a particular height and then turn it up. On Thingiverse, some people have like pre-sliced heat tower G codes. I think someone had like a generator, like an online generator, but that was a while ago, like way while ago. An A4988 with the oscillator pin turned to ground is enough for non-demanding users. Yeah, I think... Yeah, the extruder on my testbed printer is a 4988 right now. And that was doing fine. It was just a little noisy. Can you post a link to that video? I think it should just be the last video on my channel. Oh. Is this doing anything goofy? No, it's doing alright back there. Let me see what else. VD says, I got my TMC 2208 on my Delta and I can print fine at 80 millimeters a second. Still chop with linear advance, S-curve, and junction deviation. Well, that's interesting. I will have to do some experiments swapping out the 2208s and the 2130s. Because I didn't test the 2208s in Stealth Chop with S-curve acceleration. But these were skipping. It could also be some of the wacky settings that I had to do with the step race to get linear advance working properly, but we'll see. So yeah, maybe Stealth Chop 2 on the 2208s works a little bit better. But it's good to know that's working for you. Let me see. Any info on the thermocouples driver boards that they use, and E3D overprices them? I'm always sure. Yeah, one of the reasons that I like these cheapy ones is they just use a thermistor, and I don't have to worry about the thermocouple boards. Really, what they do is just do the translation of the analog signal into digital level and sends it in. Usually over SPI, I think theirs are. But yeah, so they're a little expensive because of that. But they do overprice them. I do have some cheapy thermocouple boards coming from LA Express, so I will try those out whenever they materialize. But you never know when that's going to be. About the copper shim, maybe they are putting it there to lift the carriage so the balls make contact with the top of the rail and reduce play. The friction might be a problem. That's possible. Is it on the top here, you're saying, or underneath? Like on the other side? Because yeah, it could be possible that they're doing that to reduce the play, or like add an artificial preload or something. I really wish you could preload these manually. I heard a click. Did you do something goofy finally? No. All right. Let me turn this up to 400%. See what happens. VD says, yes, Stealth Top 2 makes a big difference. Yeah, that might be it. I'll have to give it a try. Because like I said, I usually use 2208s and I never had any problems with the Stealth Chop. Christian Peterson, I have some extruder skipping with the 2208 at 8th. Can't get it to run properly with quarter. Any idea what's going wrong? Skipping, huh? Are you running it, I mean, you're going to get more torque at higher voltages, so if you're running at 12 volts, that might be a problem. Especially with a lot of the Trinamic smart features, they don't like being run down at 12 volts. I think Prusa is running them slightly over 27. Yeah, and Stealth Chopper spread cycle. I tend to always use spread cycle on my extruders. I think a lot of manufacturers have it defaulted that way too. You can always go like pull down Prusa's firmware, since they are completely in the Trinamic world, to see what they default to, because that'll kind of tell you what's reliable or what's not. And I'm pretty sure they have Stealth Chop turned off for the extruder. Bondtech extruder at 24 volts. Wow, you're skipping with a Bondtech. Yeah, I don't know. It might just be under spec motor, or you could be jamming the gears. You can try some of the Prusa folk had Bondtechs that the gears were not meshing properly, so they would remove one and test it. I had an issue with 22/8 because I had retraction speeds around 60 millimeters a second, and spread cycle fixed it. Yeah, that'll do it. Stealth Chop, like you can see in those old torque curves that I put, there are certain points where it's really good, but it really drops off a cliff, like at a particular thing. So if you have a situation where you're like fine, and then above that it's just like limp, then yeah, try switching to spread cycle. Do. Skips it retracts because of the fast speed changes. Are those geared? I don't remember if the Bondtechs are geared down or not, but that's very possible. So if you're skipping it retracts, I mean, Andre might have some information on what he did, but it could be you have to lower the acceleration in your firmware for your extruder, because you might have more than enough torque to do it, just not more than enough torque to do it that quickly. Well, yeah, Bond. Ooh, Scott. It's 3 to 1. Okay. So yeah, so you could try lowering the acceleration and see if that helps. If you're not in spread cycle, try spread cycle and see if that helps. You could also lower the maximum feed rate for your retractions. Like I said earlier, when I added a lot of these advanced features, I was able to lower it from 60 to 40 for retraction. It was fine. Well, I think I'm maxed out on speed for this print, and I didn't get it to skip, so that's a good sign. Get off there. You could tell where the cooling got a little bit ragged when I cranked it up. So this started out at let me find a good angle here. Started out at the bottom at 60 millimeters a second, and at the top it was multiplied by 400%. So that's where it kind of capped out, because the whole thing is capped at 250 millimeters a second anyway. I did up the acceleration value, and it didn't change the movement of the head, so it told me it wasn't limited by that. It may have been limited by the minimum layer time. So you can see, because of the cooling at the top, there were a couple of gaps, but that's also because of what I complained about in the last video, nonlinear extrusion. So I probably should have increased the flow rate up there, and I wouldn't have gotten these little holes in it. But the important part is it didn't shift layers, so I'll just let that sit there. How fast did it go up to? 240 was what it was set to, but you can see how complex the pattern was. So that was 240 at, it started at 2500 acceleration. I bumped that out to up to 3500 and 4K. But, with all these little Ripley's, I don't know how fast it actually got going. Alrighty. I'm starting to lose my voice, and I think that I've hit everything. So I will do a section here for questions real quick, and then I'll end it at 2.5 ellipse times. So like 5 minutes of questions or so. Yeah, the cantilever design did pretty well for a cantilevered printer. And like I said, I think part of that is bolting, right angles bolting through, so it really doesn't have anything to do except for the flex itself. Plus, it has to be on a base so that it doesn't tip over, so the base, see you, Dimitri, so the base stiffens it up a bit. And this cantilevered arm, it's not mounted on a plate between the two. That was another reason that I picked the 15 millimeter rails, was because of the distance that the 4-bolt pattern was apart. It's actually resting on the 2 bolts, and then there's a 3D printed part that just pushes down on it. So that is completely rigid. Thanks, Pauline. Thanks for thanks for tuning in. Let me see what else we've got. Alex, have you tried these linear rails? Let me try clicking on that link and hope it's nothing horrible. No, VD, but that looks like the Adafruit ones. Let me see if I can pull those up. Yeah, this right here was what I used for the Z-axis. So they were obviously a lot more expensive than the Chinese linear rail, but I wanted to give those a whirl too. And they do have, let me see if they show the bottom. It's hard to see. Yeah, so you can see they have the dual row linear bearing. They're super heavy though. Oh yeah, that's another thing. Hang on a second. So Adafruit only sold those rails in like 500 millimeter and 1000 millimeter length. So I actually cut this Z-axis down to 300 millimeters. So here's what was left. Holy crap. This stuff does not want to cut. I mean, I knew that it was hardened, but I didn't know that it was that hardened. So if you can look at what a freaking disaster the end is. Could not cut it with a carbide tipped hacksaw blade. Could not cut it with the carbide tile cutting blades, which are usually good for, like, you know, cutting stone and masonry. Could not cut it with a diamond tip cutting wheel because it just kind of scraped the diamonds off. I ended up having to grind it apart with what do you call it? Like garnet emery grit boards. Oh, what a mess. Let me see. Any thoughts on Cartesian cube with ball screws on X and Y? I have not tried ball screws for the X and Y. One of the problems with ball screws is, and just lead screws in general, is they have a ton of rotational inertia. So you'd think, like, that you're not really, you know, you don't have that same kind of looseness that you do on a belt system, but you actually have a problem of the rotation at the end. So you have a little bit of magnetic spring back between the stops as well. No, not for the X, just the Y to carry the heavier load. Yeah, so that's a little... I would imagine there would be probably a sweet spot between the diameter of your ball screw and the length of the axis, because as you're adding more length to that, you're adding more rotational inertia and you're putting more strain on the stops. But I haven't tried, other than like CNC stuff that moves very, very slowly. I haven't tried it. Abrasive cutter for hardened metals. Yeah, that's what I ended up using. Let me see. VD says I should check out a thing. Beltless hypercube. That looks interesting. Did they use force start screws? It looks like they did. That's probably a good idea. Length versus inertia. Not being a mechanical engineer sucks. I'm not a mechanical engineer either. I'm a guitar player. You should check out spring steel beds from Fizzetic. They're $20. Yeah, I might check those out. Man, finding spring temper steel cheap is annoying. Usually I go to like onlinemetals.com. They do like small metal orders like directly from Thyssen Krupp. It's basically their, you know, distributor to non-big businesses and that type of thing. And their spring temper, like 1095 steel, is like $95 a sheet, and they don't do custom cutting. It's annoying. Asker says I can't find any protection board for any step stick. Yeah, they're called the silent step stick protectors. You can get I think this is, yeah, these are focus. These are just the Fizzetic clones. You can also get them from Vatarat. I don't remember if they have them at like DigiKey, whereas I usually order my Trinamics from. But yeah, you can definitely get them on like AliExpress and Banggood. There's a version 1 and a version 2. They both have the clamping diodes, the limiting diodes, but version 2 has a startup order protection diode, so that if you start up your logic voltage before you start up your motor voltage, it doesn't screw up your Trinamic drivers. Let me see what else. All right, I guess that's it for now. I've talked long enough. thank you all for tuning into the inaugural stream here. Thank you guys for the super chat tips, and I'll be back with more videos soon. So like I said, the next few series of videos are going to be just picking apart like what I learned from this whole experience. I hope you got something out of this stuff, and yeah, have a great weekend. See you all. Thank you. Oh, and this will be posted again as a non-stream, just a regular video, if you want to make comments under that. If there's anything that you were like, oh crap, I should have asked, and I'll try to check those comments.